Alrighty, so we're on the chapter, pretty much the chapter right next to the last one. So we're just today and one more day and we're done. Yay! So covering a really big 500-page book. We did a lot of learning so far. And today we're gonna round up a little bit of that learning, showing you a little bit of error handling. So what is error handling? So let me show you. At this point, you should be familiar with open command, the context manager. We know that with we can open files, and the manager will handle the closing of the file. So we don't have to put, file close, right? All right. So here we're opening a file. We're reading from the file here in line 2, and then we're printing the contents of the file, right? And then I give it like a little empty print here just to create a new line on the screen at least. And then you're gonna print this text to the screen on the other side of the open. This makes sense, right? After execution of this suite or block of code, we should get this on the screen, okay? And to make sure that we understand what we're doing, let's look at the file, myfile0.txt. If we open this file, it says, hi, I am the contents of the file. So by looking at this code, like running it in our heads, the file is open, we print to the screen, hi, I'm the contents of the file. There's a new line on the screen there, and then we should see on the screen on the other side of the open, okay? Let's do that. Oops, let's do that. Right, just as we expected, right? Hi, I'm the contents on the other side of the open. Heck, just to make it even more obvious how this suite of code is in the middle, we're gonna put here before the open, right? And if we do that, that makes sense, right? We get that nice sequence of events, right? Our first print opens the file, prints what's inside of the file, and then prints what's on the other side. Now, what happens if we go and just change our file name in a way that it corresponds to a non-existent file? So if we go to my directory, there is no myfile.txt. Well, actually, there is a directory called like that. But you know what? For sake of the example, before we get that, let's put number 2 here. Okay, there is no myfile2 here. So what happens? When we run it, we get before the open, so we're good. And remember, I said this plenty of times before, Python, at least as of today, executes top down, left to right. So it does the first part before the open, and then when it hits the open file, we crash. And it gives us an exception has been raised. And what does it say? Well, it says, look, for our script in line 4, here's the problem in this line. When it's trying to open, right, it has an error called file not found. No such file or directory in myfile2x, right? And that's helpful, right? It lets me know that there's a problem, right? But this error is bringing the whole script down. It's not being handled. It just tells you it's an error and stops because it cannot continue, right? Notice how this part on the other side of the open is never executed because the error stops all execution, crashes it, like done. And this is bad. Imagine that you had another 3 or 4 opens here afterwards for different artifacts, right? That is a problem because it stops everything. So one solution for this is to do what's called a try except structure here. So we're gonna use it. So what does try except do? Okay. And we're gonna put print here, print. There was an error. So what try except does, it says, okay, we're gonna try this suite of code. If it works good, excellent, continue on. If it doesn't work good, there's a problem, take the exception and do something with it. In this case, I'm saying print there was an error, and then it continues. So this is important because if this goes wrong, it's okay. The program's not gonna crash. It'll continue execution from that point onwards. So let's try it. Let's see what happens. Yeah, look at this, right? Before the open, we had a problem. There was an error on the other side of the open. So that's pretty neat, right? We can now move, and again, just make it like a little bit better like the other one. We can just kind of say, okay, there was a problem. We can identify it and move forward. Now, What's the problem with what I just did here? When it says there was an error, what's the problem here? Is this useful? When it says there was an error, do we know what type of error it was? Do we know what happened? Imagine if I did this. Just say, okay, this part is giving me problems. Let's just hit pass. And if there's an error, just keep going. How about here? Would you have any idea that an error occurred? Does that make sense? If that makes sense, give me a 1. Are we seeing ones, Brooke? Okay, well, I'm gonna assume that we do. All right, so we don't want to do this, right? We don't want to just do the accept and just hit pass or just hit print. There's an error because we won't know what the error is. We won't know what to do with it. All right, so I'm gonna show you another example here. Let me take the tryout again. All right, and let's make sure that it works as we expect it to work normally. Okay, now it's working fine. Now I'm gonna change it to myfile.txt. And actually my file.txt is not a text file, it's actually the name of our directory. So let's see what happens when we do this. All right, we crash as we expected, but notice the error is different. It says on this file, on the 5th line, as it's trying to execute this call to open myfile.txt, it notices it's a directory. Oops. It's a directory. So this is a different error, right? As opposed to there not being a file. So it's a directory error versus it's a file not found error. There is actually a big, long hierarchy of errors when something bad happens that the interpreter will let you know about, okay? So the best way of doing or dealing with this, at least that I use, that I recommend, is the following, right? Use your try for your block of code. That's fine. And then actually I want this here. And then when you're gonna do your accept, what you're gonna do is take the exception class, all right? That's the class that determines when an error happens and inherits the actual exception that happened. It will inherit if it's a directory error, if the file is gone, and place it or take it and instantiate it as ERR. You can name it. You can name this whatever you want, right? And then we're gonna print the error was and then call the exception out. So let's see how that looks. All right, look at this. This is pretty nice. So it says the error was, and it tells me the error number, and it tells me it's a directory, right? So that's way more readable. That's pretty nice. I still get to know what happened, but it doesn't crash my program, right? Usually what I would do is I would put like a little notice on the screen, and then I will go and say, okay, I would say, for example, I would I mean, this is just a kind of made up example here, but with open, and then I would open, let's say, error log, for example, right? .txt, for example, as whatever, error, yeah, let's put that there, that's fine. And then I would, and again, I'm not gonna do the whole code, but I will write the error to the log, right? That's logging. And this is really useful because it gives me control of what the error is. If I wanna log it, I log it. I might want to send something to the screen. One thing I really encourage you all is to don't fail silently. If you did a script, use try accepts to make sure that if there's an error, it doesn't crash, and if there's an error, that you can handle that error or at least get a notice of it. An example that it will come across your work a lot. You have a query for a SQLite database that you used a lot, and all of a sudden next week they changed the schema of the database, which means a table disappeared, or there's a new, well, I say table too, but what I should have said was a column of your query disappears, a new column shows up, maybe they rename it, which means that your query is not gonna work, okay? So you need to handle that error so you know that you need to look at that query and change it, and then, you know, make a query for that version of that database, for that new schema of that database. And that's not the only type of error you're gonna find. You might find malformed files that you can't open, and you need to handle that error to make sure that you know that there's a problem there. You might find all sorts of errors, right? So with that being said, remember, any block of code that you want to make sure that it executes properly, and you want to make sure that you know what the error is, if any, without crashing your script, use try, the portion or the suite of code that is going to be executed to do that investigation, to try it, and the except. What happens when if it fails, or when it fails? It, you know, it depends. And notice this is a thing we use with Python. Try, and then the block of the code is going to be indented, right? Same thing with the except. The same way we do it with our for loops, our while loops, our if and else's, all control structures, the same way. We're going to handle it that way. And with the colon here at the end. Okay. And actually, let me show you one more thing. If my memory serves me correct, let me see if I can, actually, I think I have it open here. View, no file, there we go. So let me show you here an example of when I use it. I think it's in, search files. All right, so look at this code here. So what I'm doing here, I'm not gonna explain the whole code, it's a lot of code, but I wanna point your attention to the try here and the except here. So what am I doing here? I'm doing a list, I'm looking in a tar file, and I'm trying to match a pattern to the contents of files or directories inside that tar file. And now I'm gonna try something. I'm gonna make sure the paths are correct. I wanna make sure that everything is properly set, right? And I'm gonna open the file, do things with it. I'm not gonna worry about all this code, but this is the part that matters. If something inside of here, me checking the path, copying that out for later analysis, if there's a problem in here, I'm gonna say there's an exception, all right? And I'm gonna say could not route to file system, right? And the path was, and whatever it was, the path that was the problem, and then was the error that the interpreter gave me that was raised. And the reason I put here could not write to the file system is that based on this code, the most likely culprit, 99% of the time, actually, I'm not gonna say 100 because I don't know everything, I don't know the future, but based on this code, most likely is because you couldn't write something to a file system because there's an illegal character or some other weird reason. So that's why I put this here. But the important part is raising the exception and taking the message and make sure you keep it there. And if you look here, I'm using a thing called log func. That's something I made that I coded. And what that does is it sends the data to the screen for the user, and it sends it to a log so we can actually then read it later. So actually, let me show you that, and that will be it. Let me sneeze for a second here. All right, here it is. So it's a pretty simple function. What it does is I opened a file, right? And append, because I'm gonna be adding errors as they come in. And before I add it, what I do is I go and print it to the screen for the user to see as the program is executing. And then I take the write and I write the message to the file, right? Does that make sense? So in my coding, I use this structure in my coding. I check if there's an issue at the code. And if there's a problem, I send that problem to the screen and I send that problem to the log. And I did my own little function here that opens a file. And then after it opens it, it sends the message to the screen. And then it sends the message here in line 95 to the log. So then, you know, after the program is executed and whatever's on screen is gone, we have a copy of that in a log that we can actually look at. All right, and that's all I got for today. So not a lot of stuff in a pretty condensed time, and I think it's something really useful for your coding. You will find yourself doing a script that does many things, right? It will look at a query for a database, may run another query and another query and another query. And you want to make sure you use try excepts for each. So if one craps out, it doesn't bring the program down. It doesn't crash the whole script. And then you can figure out what the error was after the fact, fix it, and then run it again, right? Any questions, comments? If this made sense, give me a 1. Brooke, is there any ones there?
Yep, all ones.
All right, perfect. So so that's all I got for today. For next week, I'm gonna read chapter 12. Chapter 12, I recommend.
Thursday.
I'm sorry, Thursday. My bad.
Sorry.
I don't know. This whole
days, time vortex.
I mean,
time is meaningless, but continue.
I mean, it's been like what since January. It's been like what 3 years already. I mean, I don't even know what's going on. So for Thursday, chapter 12, I'm just gonna cover the section on comprehensions. But the whole chapter is really good. I highly recommend it because it teaches you different coding patterns on how to do loops, iterations, searching through things more efficiently. So I highly recommend you read the whole chapter to optimize your code. I'm just gonna touch on one little part, that's comprehensions. It's really a Python way of doing things, or Pythonic way of doing things. So we'll talk a little bit, just introduce it, and then we're done with the book. So thank you so much, everybody, watching. I'll see you for last class next video.